Hello everyone. Sorry for that. Okay, let me now check if I'm audible or not. Okay, so I guess now I'm audible. So okay, let me start this again. All right. So this side Ayush and Tripathi, our DSM mentor and problem setter at Geeks for Geeks, and welcome you all to this post analysis of Biwizard School Coding Tournament 18. And we would be only discussing coding problems here because I don't think quizzes are not quizzes are very hard to search. So you guys can easily search the topic and read about that topic in as much depth as you want. So this will be your homework task, that is upsolve the quizzes. All right. So we have three problems, and this yet another problem was the easiest one, then this one, and then the hardest problem for this contest is find minimum cost. So we start with this yet another XOR problem. Okay, thanks Utkarsh for confirmation. So yes, so in this problem, yet another XOR problem, we have an array consisting of n integers of, okay, really sorry for that. Actually, I forgot to share my screen. Hello. All right. So I guess now I am audible. Actually, uh, this camera is connected with the or connected with my microphone. So when I turn off this camera, then the microphone also gets turned off. So that's the reason why I am not audible. So hope now I'm perfectly audible and visible. And I really sorry for that. I hope everything will be fine now. So we are going to discuss this first problem where we have an array consisting of n integers, and we have constructed another array b such that every element bi is equal to ai XOR n, and this array b is known to us. Then we have another integer x, and our task is to calculate XOR of each element of array A with X. All right. So let me just quickly explain the problem statement. So initially we had array A. So that is A0, A1, A2, and so on till A of n minus 1. Right. Then we constructed array B such that every element Bi is equal to Ai XOR n. So B of 0 is equal to A of 0 XOR n. Then B of 1 is equal to A of 1. So A of 1, B of 1 is equal to A of 1 XOR n, and so on. That is B of n minus 1 is equal to A of n minus 1 XOR n, right? And only this B array is known to us, and our task is to return array such that every ith element is equal to ai XOR x, where integer x is given to us. So we need to return an answer array such that every element answer of I is equal to ai XOR x, and this x is given to us. So we need to find this answer array, right? So to find this answer array, we first need to extract ai, right? And from this array b, we need to extract ai. And you only need to know about two properties of XOR to extract this extract element ai from array b. And those properties are x XOR x is equal to 0, and x XOR 0 is equal to x. You only need to know about these two properties, right? So let me just write this thing over here. All right. So what we had array b, right? And we know bi is equal to ai XOR n, right? So then what we do, we XOR both sides with n. So that is bi XOR n, then ai XOR n XOR n. and and because of this first property, this n XOR n turns out to be 0. Then ai XOR 0 is equal to ai. So more formally I can say ai XOR AI is equal to BI XOR N, right? And i- with this way, we extract every element A of I, right? So is this thing clear to everyone? Please write a +1 in the chat. All right. And once we get this array AI, then we simply take AI XOR X, which would be our resultant array. So that is answer of I is equal to AI XOR X. And now we know AI, and this X is also given to us, so we can simply find this answer array, right? So this was all about explanation and observation. Let's see how we implement this entire solution. Okay, I wrote like the same solution, but it was showing incorrect output shown unexpected intent. Okay, so what you can do, you can post your solution in the comment, and I will answer your doubts over there. So how we can implement this yet another XOR problem? So what we can do, we can first extract AI from this B array, right? So let me just create another vector A of n, right? Then yes, exactly, Kush. So then we extract this AI, and AI is equal to BI XOR n, right? Then we create up our answer vector of size n. Then we update our answer of I is equal to A of I XOR X. Then we simply return our answer. All right, let's try to submit this. Accepted. And the time complexity is linear O of n, right? So this was about first problem. Then the next problem that we have is ABC hunt. And actually this problem was prepared by me, and I hope you guys enjoyed this problem. So you are given a string consisting of characters A, B, and C, and our task is to find minimum number of characters that must be examined starting from left of the string in order to ensure that all three characters A, B, C occur at least one. So we need to move from left to right, and the moment when we get all the three characters, then we simply return that index according to one base indexing, right? So for this first example, after examining the fourth character, we can see each characters is having at least one occurrence ABC, right? Here, if you only examine first two characters, then we only have A and C. And if you examine first three characters, then again we only have A and C. And after examine the fourth character, then we got all these three characters A, B, and C. All right. So let's see how we can solve this problem. And there exists a multiple method to solve this problem, but I'm going to explain you the best way to solve this problem using bits, right? So what we know, we only need to check the occurrence of three characters, right? So let's say this is A, this is B, this is A, A, this is A, this is B, and this is C. And why I am writing in reverse order? Because in alphabetical order, this A is having zero value. That is not actually alphabetical order, but what we can say. Okay, let's just leave it. So this A is having zero value, then 1, and then 2, right? And we only need to check the occurrence of A, B, and C. So what we can do, we use bits, right? We use a bits, and if the moment when we get that all these three bits are set, then this means we got all three characters A, B, and C. So we simply return our answer at that moment, and the value of this binary this binary representation is 7, right? Because this bit is having weight 2 to the power 0, then 2 to the power 1, then 2 to the power 2. So 2 plus not 2 actually, but 4 plus 2 plus 1, right, is equal to 7. So the moment when we get that this value is equal to 7, then we simply return our answer, right? So let's see how we implement this thing. And okay, and to store this information, we use a variable. So basically this is nothing but a variable, right? And for every character, we mark their value bit in this variable as true, right? Or we set that bit. So let's just quickly implement this thing. So first we take the length of this string s. Then what we do here, this variable, let's say answer, will store that whether we encountered all the three characters or not, and we initialize this with 0 because initially we didn't encounter any characters. So we initialize all the bits as 0, that is 0 0 0, right? So then we iterate over the characters. So let's say auto C S, right? And here ch is the ith character, right? We can say. And also we initialize our count, that is number of characters that we need to examine, right? Then what we can do, so we simply, okay, so we simply take or with answer and the value of current characters. So that is answer or is equal to ch minus a, right? And the moment when we get that answer is equal to 7, then we simply break this loop, right? And also we increment our count, that is we have examined one more character, right? So then what we can do, we simply return our count, right? So let's just try to submit this. Okay, we got some compilation error. So s not declare. Okay, so actually it's capital S, not a small s. So let me just quickly change this thing, and here as well. All right, here we got our answer is 5. So let's see why we got this error. All right, so actually we have incremented this answer first, then we are breaking this loop. Okay, just wait a minute. Let me just quickly check why I'm getting wrong answer. Let me just quickly check why I'm getting... 。 . 。 。 。 . 。 . 。 . 。 . 。 . 。 . 。 . . . . . . . . 。 . . . 。 . 。 . 。 . . . . 。 . . 。 . 。 . 。 . 。 。 . . . . 。 . 。 . 。 All right. So actually, what I did, actually, I forgot to set the value corresponding to this character in our answer bit, because here what we are doing, we are simply taking or with the value, but we want to set the bit corresponding value of the bit corresponding to this ch minus a. So we need to use a left shift operator, that is one left shift. So let me tell you again. So let's say, so this b is having value 1, so we need to set the first bit of this variable as 1, right? So we use a left shift operator. So that is what we do, we shift 1 by 1 time, right? So that is 1 left shift 1 is equal to 2. So we set this bit, right? So actually it's not, it's actually 1, right? 1 left shift 1, right? So yes, we set this bit. So then we check if answer is equal to 7, then we simply break and increment count. So now let's try to submit this. All right, again we got some error. Don't know about. Okay, sorry for that. But here we need to increment. Okay. Okay, all right, accepted. So, and the time complexity is linear, right? So please write a +1 if this problem is clear to you, or you guys need any more explanation. All right, so let's just solve the last problem, which is find minimum cost. So here we have an array weight ARR containing weights of n boulders, and where weight of ARR is the weight of a boulder kept at index I, and we have to decide an index k from integer 0 to n minus 1, where we have to set up a processing unit to crush boulders into a fine sand, and we need to move all the boulders to that index k, and the cost of moving ith boulder to index k is weight of ARR of I multiplied by the absolute difference of k minus 1. And our task is to select such index k such that the cost will be minimum, right? So let's take this example. Okay. All right. So what we can do, we shift this shift the boulder at index 3, which is this one. Okay. Or we can say index 2 if you considering zero based indexing. Then cost of moving all the boulders are 1. So for the first boulder is having index 0. So let me write the indices as well. So 0, 1, 2, and 3. So we select the value of k as 3. Then the total cost, incurred cost, is 1 multiplied by absolute of 3, not 3 but actually 2, minus 0, which is for first boulder, which is 2. Then for the second boulder, 3 multiplied by 1, 2 minus 1, right? Which turns out to be 3. Then 1 multiplied by 2 minus 2, which is 0, then 6 multiplied by 3 minus 2, which is 6, right? So the total cost that occurred is 11, right? Which is the minimum one. So let me just quickly check. Actually, it's 10, where I did wrong. Okay. 3 into 2, we select the value of k as 3, right? So actually we select this thing, right? So if we select, we have what we did, we selected the value of k as 2, this one, boulder one, right? So according to zero based indexing, right? So this will giving the cost 11, but this is not the minimum one. We can achieve some better answer. So let me just write here k is equal to 2. Now what we do, we select we select k is equal to 3, that is last boulder, this one, right? So here we set up a processing unit. So then what will be the total in occurred cost? So it will be 2, 1 minus 3 minus 1, and not actually 1 but actually 0. So the total cost that in occurred is 3 for the first boulder to move at index k. So here we selected the value of k as 3, then 2 multiplied by, not 2 but 3 multiplied by 3 minus 1, where 3 is the value of k and 1 is the value of current index of current boulder, which is 2 into 3, which is 6. Then for third boulder, 2 multiplied by 3 minus 2, 3 minus 2, which is 2. Okay. 3, okay, just wait a second. Okay, actually it's not 2, but actually here we have 1, right? Then for last boulder, 6 into 3 minus 3, which is 0, right? So the total cost that in occurred is 10, which is better than the previous one when we had selected the value of k as 2, right? So selecting this boulder will give you the minimum result. So now let's see how we can solve this problem. So let's solve some easier version of this problem. So let's say we have a number line. So this is a number line where we have multiple integers, right? So let's say this is integer x1, then x2, then x3, then x4, then x5. And now our task is to merge these points into a single point. That is, move all these points and merge to a single point, and the cost of moving the point is x of k minus x of I, right? This will be the cost of moving a single point, right? So here the k is the point that we have selected to merge all the points. So let's say we have selected the value of k is equal to 2. So we need to merge all the 3 points from left to this x2 and all the points from left to this x2, right? And we want to minimize our total cost, right? So how we can solve this problem, and which index is helpful to select, right? So to minimize the answer, it's always helpful to select the closest value to a mid integer, right? So we select this x3. There might be a case when the closest value to a mid integer is x2. And why I am saying this? So let's assign some values. So let's say this is having a value 1, then 2, uh, what we can say, then 6, and then 7, and then 8, right? So we sum all these three integer and select the midpoint where we merge all the points, right? And that would give you the minimum result. So using this idea, what we can do, we try to select a minimum point, a midpoint where closest point to the mid, closest index to the mid, right? And for that we need to keep track of two things, uh, left and right. So the weight of boulders in the left of every index and the weight of boulders in the right of every index, right? So let me just write a complete algorithm, then I will explain you side by side. So what we can do, we initialize our left variable and right variable both with 0, right? And then we update right with sum of all the boulders weight. So right is equal to sum of array, and here array is actually denoting the weight of boulders, or just like a weight of ARR as per the problem statement, sum of ARR, right? Then we start moving through all the indices, that is from 0 to n minus 1, where n is the size of this array, right? So what we can do, we first move this element, ith element, from left to right. Okay, let me just check the chats. Okay, okay, just wait. All right, so we start iterating from 0 to n minus 1, then we move current boulder from left to right. So let me just write indices over here. So if this is our initial array and currently we are at ith element, so what we do, we move this ith boulder from left to right, and all these boulders are in the, not actually left to right but actually right to left. So this is our left and this is our right. And how do we do that thing? So we simply subtract the value of ARR of I from right and add it to left. So then left is equal to weight of ARR of I, and actually we add this thing now. So left plus is equal to weight of ARR of I, then right is equal to right minus is equal to weight of ARR of I. All right, then what we do, we check, we add minimum to our answer, and also we initialize our answer, which is storing the minimum cost that in occurred. So we add minimum of these two, answer plus is equal to minimum of left comma right. And why I am taking the minimum? Because if this value, if this ith index, that is the cost of all the indices in its left, is less than the cost of all the indices in its right, then it's not helpful to select this index. We select the index from its right, right? Because of this is uh, this this explanation, that we, to minimize the cost, we always select the value closest to mid, right? That's why we try to select the value of index greater than I. So here taking minimum of left comma right, and after this iteration we simply return our answer. Return answer, right? So let's see how we implement this. Okay, so I have already drawn this code. Let me just clear this thing. All right. So here we have answer as 0, then a left and right. So here what we are doing, we updating this left case. Actually, we need to first update this left, right? So let me just quickly update this left. So how we update? We simply add the value of all the elements. So that is right plus is equal to weight of ARR of I. Then here what I did, I taken another variable total instead of right. So let's take the total only. So we initialize right as 0 and total as 0. Then this is actually total. So what we are doing, we updating this right. So that is right is equal to total minus left. Then we are adding minimum of left comma right in our answer. Then we update our left, that is adding the current element in left. So what I mean by this, so this is actually not here, but actually here. And why it is here? Because if you select the ith element, ith index, then the cost for this ith boulder will be 0, right? because because k minus k, so that is arr of k, the cost for the boulder that we had selected is k, is having index k, then the cost for this boulder is arr of k multiplied by k minus k. So this turn out to be 0. So that's why we add the boulder in the left after this examination, right? So after checking this, we update our left now, and after this for loop, we simply return our answer. So let us try to submit this. All right, weight of ARR not defined. Okay, it's actually weights, not weight. All right, accepted. And the time complexity is again linear. So this was all about explanation and observation. So let's just wrap this session over here. Or you guys can go ahead with your doubt if anything is missing to you. All right, so I don't think there is something. So thank you for joining this session.